Okay, this is one of those final days of prep for the semester one final in Honors Pre-Calc, and I've got a packet out there, which is your take-home final, and somebody asked me about number 8. I can't do number 8, but I can remind you of stuff we did that's similar. So for instance, do you remember on the top 20, it would have questions like this. How would you clear the fractions out of this? This has been a theme all year. If there's fractions, clear them. So you multiply by, yes? Yes, exactly. I like the idea of multiplying by 2. That would clear the 2. Multiplying by 3, that would clear the 3. But why don't you multiply by 2 and 3 at the same time? Like this. And then you'd have cancel, cancel, 3 plus, cancel, cancel, 2n equals 30. And then it's, look, Mom, no fractions. So much easier. Well, same thing on your problem. Clear your fractions. And then that brings us to the topic of if you clear those fractions, you're going to end up with a quadratic. And let's say you had a quadratic, let's say it was like this. X squared plus 6x equals 8. Well, first of all, you always start with the quadratics, you set them equal to 0. Then, if you can factor it, you should. And what if you can't factor the thing? So, here's one. Can you factor this? It kind of seems like you should be able to, because 4 times 2 makes 8, and 4 and the 2 make a 6, but it turns out you can't factor this. We'll save some time. And then you'll be like, okay, well, I guess I can't factor it. Can I still do it? Well, let me make you think about quadratics for a minute. Do you agree that that is a parabola that is not upside down because there's no negative in front? Would you agree it's a U-shaped parabola? So if you kind of just picture where it is, it's got a y-intercept of -8, and it's a U-shape. So it's like this, or it could be like looping through the other way like that, but either way, it's down there. Bottom line, does this thing touch the x-axis? Yeah. Those are the roots, the zeros, the x-intercepts, the solutions. If you're going to solve a quadratic, you'll always have to set it equal to 0. If you can't factor it, quadratic formula. All right. Now, one more thing within the quadratic formula. In your packet, again, somewhere, not even saying where, you'll figure it out, this comes up. You're solving this equation, and you're wondering whether it has 2 solutions or 1 solution or no solutions. Does that sound familiar? One of the questions says something like that. All right. I already did this one a second ago, and I graphed it, and I know what it looks like. So what if I change it to that? Does it have solutions or not? Well, I'm going to graph it once. It's a U shape, goes through 8. How low does it go? That's the question. I don't know how low it goes. So I don't know if it goes low enough to touch or not. Do you get if it doesn't go low enough to touch, then there's no real solutions? How can you tell if it has solutions? Discriminant. So in this big formula, this spot is special. That number, if it's negative, there's no solutions. If it's positive, there's 2 solutions. I paused for especially a long time there. And then if it's equal to 0, there's 1 solution. This is one of the least known formulas for Minnetonka kids. Not the quadratic. Everybody knows that. But the discriminant and this right here. I bet you, if your life depended on it, about a third of the class would not be able to tell me what that does. Negative b over 2a. Don't say it, please. I bet you a lot of you do not know what that does. It's very handy. It finds you the, raise your hand if you know it. Oh, it's less than I thought. Less than half the class knows. It finds you the vertex. Very good. It finds you the vertex. You may want to know that one. It's very powerful for the ACT also because you might want the vertex for a million reasons. The vertex is the low spot, also known as the minimum. Or what if you're doing a graph and they want the maximum? That's the high spot, also known as the vertex. So there's a lot of reasons you might want the vertex. How about to write the equation in vertex form? Sounds handy to know the vertex then. All right, so x equals negative b over 2a is the formula for finding the x of the vertex. Some people are like, okay, so then what's the y of the vertex? All you got to do is take whatever the x number was and stick it in the equation. And it says y equals, for most equations, right? You'd then be able to solve this for y. If you knew that x was like 1, just put a 1 in. In fact, why don't I just do that? Everybody right now, for this equation right here, the one I have on the board, would you please find the vertex for me? That's a doable, that's a question we could ask you on the final. It's also a question you could know from for the ACT. So if you aren't already using this, negative b over 2a, use that. Did you get negative 6 over 2, which would be negative 3? But remember what that is. That's x. X equals negative 3. If they wanted the axis of symmetry, that's the axis of symmetry. It's that. That's the axis of symmetry. So then you stick that back in the equation. Goes in here. And you'd have the final answer of your vertex is at negative 3 comma what? And I'm just going to do it. This is 9. This is negative 18. And this is an 8. I'm going to put these two together first, and it's going to make negative 10. And then I put that with the 9, makes negative 1. Negative 3, negative 1. So if I actually look at my graph, which I suspected looked like this, I was totally wrong. It actually looks like that. So it did have a vertex that was below the x-axis, so it does have roots. There's 2 of them. All right. Okay. That answered a question on the packet, whether or not you know it. One of your questions asked about something like that. So what else do you want to know about pre-calc? I can do it all. Any topics that are on this packet, or even just because you know we studied it, but we haven't talked about it much lately. Yes?
On number 7.
Okay, would everybody look at number 7, please, just to see if you already have that down. I'm going to ask you to read the end of it. What does it say at the end of it? Exactly 2 solutions. That sound familiar? That discriminant thing we just did. Remember the discriminant thing? The discriminant, if the discriminant is positive, is one thing. If the discriminant's negative, it's something else. This is one of those cases of the discriminant. And if you know the discriminant formula, I'm going to tell you. That's the other one I was saying was in this packet. That was just like what I just was talking about. All right, yes. Go ahead. 4b. Everybody ponder 4b for a moment. And problem 4b. All right, that is the difference quotient. And it's got a fancy name, but basically what it involves is finding things like, I'm not going to do the one you have, but this is similar. Okay, and let's say my function was this. F of x is 3x minus 7. Okay, I guess yours has 2 variables. It won't make that much difference, but I will use 2 variables. X plus a. Okay, let's say I wanted to find that. All I got to do is stick this into this equation. So it's 3 times what you're supposed to stick in, and then bring this down, and you just multiply it all out. So there was one that was a little more complicated. Let's say it was f of x plus a minus f of x. And first I'd do the part I just did, and then I would go minus, what is f of x? It's that. All right. Nobody has asked me about inverses yet. Are you all good with inverses? All right. Yes. Oh. Okay. Just, you realize I'm not going to actually answer 8b, but you're saying you think I didn't, because see, here's the thing. What you don't realize is that's just a fraction. And how do you clear fractions? Okay, so here's the thing that maybe would help. What if I had 5 to the negative 2, just to start with that one? What's 5 to the negative 2 mean? I know it's not the same question, but it's the thing in the question that's bothering you. That would mean 5 squared, and then what? Can you guys do this? Maybe you guys all don't know what that is. If you know that, write it down. If you don't know that, I should talk to you about it. Negative exponents, fraction exponents are a big deal in this class. So if you don't know this answer, you got a problem. Okay, did you have 1 over 25? Okay, then you're on the right track. So it's two parts. I like to think of it as negative 5, or sorry, 5 to the second, and it's to the negative 1, because it's kind of two different things. The 5 squared, that's easy, that's 25. A negative power means 1 over. So do you get how all of a sudden this is actually a fraction? See what I mean? So this gives you a fraction in your equation, and then you want to clear that fraction. All right, I think you're getting it now. Okay. So if you had this in an equation, if I had a plus 5 to the negative 2 equals 17, this is really a fraction, so you should multiply everything by 25. Because that's really this, and then 25 will clear the fraction. Okay, enough about that. Sounded like you guys felt like you were good with inverses. How about odd and even functions? Do you remember those? Do you remember the rules for odd and even? Do you remember if that's the odd rule or the even rule? Do you even remember that at all? You had that this semester. Now, I think some of you are bound to the whole, like, well, I got this packet here, and that's got everything. No, that doesn't have everything you've studied. It's got a bunch of things you studied, but I'm obviously bringing it up for a reason. So is this the odd or the even rule? And maybe you should take notes and realize you're going to be handing this packet in. So don't take notes on the packet, because you're going to be handing that in to me on Friday. But unless you already know if that's the odd or the even rule, and then could tell me the other one, you don't know this well enough to not take notes. It's your life. I don't take the final for like 5 days. You think you're going to remember this conversation 5 days from now? All right, so I'd write it down. The palest ink is better than the best memory. Mr. Server say. All right, ready? So if I had a function like 2x squared minus x, is it an odd function or an even function or neither? All right, so, well, which was this rule again? Somebody out there knows it. Is this the odd or the even? You had a 50-50 chance. Thanks for giving it a shot. It's the odd rule. Okay, so I like to say it this way. It's got a negative on the inside, and there's one on the outside. Huh, that's odd. The negative can move. It's the odd rule. All right, so what's the even rule? Even rule starts exactly the same. And that's the even rule. Oh, it's coming back for some of you. It did take like 2 or 3 days on this and you got tested on it. So it's there. You just have to drag it up out of the murky depths of your memory, the tar pits. Okay, so let's do one. Is this odd or even? And you'd have to prove it. So the first thing you'd do is you would stick in, move these guys down. Neither is, it didn't work for either of those rules. There's no rule for even, no. It's just you either the one works or the other works, and if neither one of them works, it's neither. All right, so here is a typical question. Right now, follow along through this with me if you actually want to know how to do this on the test. All right, so if this is odd, that means if I put in f of x, well, first of all, y means f of x, right? And if I want to find f of negative x, f of negative x is saying, go through and put in a negative x wherever there was an x. There, I just put in negative x everywhere. And then I simplify it down a little bit. Would you agree that negative x quantity squared is the same as x squared? And minus minus x means plus x. Is this ringing a bell for some of you yet? And then you had to see, is this equal to this, and is this f of x? Yes or no? Is that the same as f of x? No, because f of x is up here. And so the answer is not even. You always check for even first because it's simplest. You just stick in a negative x and see if it comes out to f of x. Then, see if you remember this part. I'll make this in blue. F of negative x is equal to, I'm factoring out a negative 1. Remember that thing? Factor out a negative 1 and I end up with negative 2x squared minus x. And then, that's the odd rule. See, it's right here. It's written, and it shows you that if you have a negative in front of f of x, then it's an odd function. So, is this right here? Is that f of x? Nope. So final answer, this was not odd. So if it's not even and it's not odd, it's called a neither. All right, if I try this one. Prove that it's either even or odd or neither. Even, odd, or neither. Now I've included stuff in first hour, my first pre-calc class, I should say it that way, that I didn't teach in here, like for the review day. And I'm recruiting this stuff that I'm doing with you right this second. It's stuff that I didn't teach in my first pre-calc class. And then in my next pre-calc class, which is actually 6th hour, I'm going to record something even different than that. So if you want tips on all over the place from all over, watch all 3 of these videos. Fast forward through the stuff you already know. Okay? All right. So, how many of you knew you were supposed to put in f of negative x? Okay, good. It's a good start. And then I'm going to go negative, and then negative x. And then I'm going to simplify it. Negative of that part comes out positive. Whoa! That is f of x. Therefore, it's even. That was a pretty easy one. How many of you did come up with it was an even function? Okay. Because this is f of x. See, it's right here. They are identical to each other. Then really, f of negative x came out to f of x. And that is the rule you're supposed to look for even. Judging by how many quizzical looks I got, I'm going to try one that's odd. Would you see if that's an odd function? I already said it's odd, but would you prove it? Prove that that's odd. is really f of x. And so then I go f of negative x, and then I stick in a 3 negative x to the third, and I simplify it down. And then I look at it and I say, is f of negative x equal to, is that f of x? Because if it is, I've just done the odd rule. Wait a minute, no, I just did the, yeah, I was checking for even first. If this was f of x, is that the same as f of x? No. Therefore, it's not even. Now I do one more step. I factor out a negative 1. Negative 1 comes out. What do I have left? Back 3x to the third. And is that f of x? Yes, it is. Yep. So negative 1 times, is this f of x? Yeah, that is f of x. Yes. So, therefore, this is odd. Because f of negative x is equaling negative 1 f of x. And that's the odd rule. That's one of the things we did this semester. In next hour, in 6th hour, I'm going to be doing zigzaggy graphs. Do you remember these? And then you had to do like, let's do absolute value of f of x. You remember that? And what if we do the absolute value on just the x, on the, like the absolute value on the inside? That would be like, hey, if this is f of x, what would f of the absolute value of x be? Again, I'll remind you, if you want to watch that video, I'm going to post that again later today. Okay, so again, not everything that's in your packet everything that's on your packet is helpful for the final, because it's part of the final. But some of it's going to get repeated again on the final. But there's other things, too, that we learned this semester, besides what's in your take-home test. All right, I think I want to stop and give you more time to work today than on a normal day. And if you want, go tune in and watch what I do in 6th hour to get some more review of some different things. And if they all ask me the same questions as you, I might refer them to like these videos and, again, try to go to different topics. Okay, any other last questions? All right, that's all I have for the video for today. And tomorrow, we are correcting, hard deadline, the take-home final. So make sure it's here. If it's not, you're going to end up turning it in late. You're not going to get it graded for like a week and a half, and it's going to have a 10% penalty. None of that's going to be fun. So strongly recommend being done and ready tomorrow. Okay.